Lenses and ray diagrams. In this lesson, we're talking about mirrors versus lenses. We're going to review lens types. We're going to talk about the converging lens rules, the diverging lens rules, ray diagrams, and then locating images using converging and diverging lenses. Mirrors versus lenses. Drawing ray diagrams with lenses is similar to drawing them with mirrors, except with mirrors, we are concerned with the reflected rays, and with lenses, we're looking for the refracted rays. Types of lenses review. There are two main types of lenses: converging lenses that we have in the top here, and diverging lenses that we have on the bottom. Converging lenses converge or bring together the rays, as you can see here right at the focal point, whereas diverging rays diverge or push the rays apart. And what we do is we extend the refracted rays back towards the principal axis. And where all the extended rays meet is the focal point. Another term, we can simplify our ray diagram to have one incoming and one outgoing ray. In lenses, we call the incoming ray the incident ray and the outgoing ray the emergent ray. So we have the incoming ray or the incident ray here, the ones going into the lens, and then we have the emergent or the outgoing ray here on the other side of the lens. Converging lens rules. Number one, a ray parallel to the principal axis is refracted through the principal focus. So we can see that here. We have our first ray right there. It goes to the lens, and then it goes through the principal focus right there. Number two, a ray through the secondary principal focus, which is the same distance away as the focus but on the other side of the lens, is refracted parallel to the principal axis. So the ray goes through the secondary principal focus, hits the lens, and comes off parallel to the principal axis. Number three, a ray through the optical center, that's this guy right there, continues straight without being refracted. Now, diverging lens rules. Number one, a ray parallel to the principal axis is refracted as if it came from the principal focus. So there's the principal focus there. Our ray hits the lens and then is refracted out as if that ray originated from the focal point. Number two, a ray proceeding towards the secondary principal focus, that's this guy here, of a diverging lens, that guy right there, is refracted parallel to the lens axis. So the ray comes in, it hits the lens, and it comes out parallel to the principal axis. So you can see if we were to extend this ray where it was going before, it would continue straight on right to the secondary principal focus. But when it hits the lens, it changes direction and goes parallel to the principal axis. Number three, a ray through the optical center continues straight through without being refracted. Ray diagrams. We use ray diagrams to draw our images, just like we did for mirrors. There are three different rays that can be drawn, but you only need two. Choose the ones that make the most sense to you and the situation. So for instance, if our object was drawn in front of the secondary principal focus, you couldn't draw a ray through the secondary principal focus, so you wouldn't be able to use that rule in order to draw that diagram. Locating the image. So you can see how we can use our rays that we described previously in order to draw our image. The image is over here in the gray, the object is over here in the green. So you can see the rays. We have rule number one, where it goes parallel to the principal axis and then goes through the focal point. We have ray number two, which goes through the secondary focus and then comes back out parallel to the principal axis. And then we have ray number three that goes through the optical center and just continues on. Where all three of them meet, that's where our image is. But we can find that image with only two rays if we only have two. So I want you to pause the video and I want you to try this one in your notes. Okay, so let's give it a go. So the first ray is going to go to the lens, and then it's going to go through the focal point. So that's our first ray. The second ray is going to go through the secondary principal focus, hit the lens, and then come off parallel to the principal axis, like that. Now again, that would be enough to find our image, but we can also draw a third ray here just to make sure. So the third ray is going to go through the optical center and continue on. So where these three rays meet, that's going to be where our image is located, just there. Now this one's going to be a little more tricky. So what we're going to do is we're going to draw our first ray, we're going to go to the lens, and then we're going to go through the focal point. The second ray is going to go straight through the optical center. And you can see how they're diverging, they're getting further and further apart. So they're never going to come together. So what we need to do is we need to extend the refracted rays back and see where they meet. So where the virtual rays meet, that's where our virtual image is going to be. Let me draw with dotted lines because it's a virtual image. Now here's an example of finding an image using a diverging lens, and you can see our rules at play. Now I'd like you to pause the video and find the image associated with this object. So the first rule we're going to use is we're going to take a ray that comes off the top of the object and hits the lens. Now when it refracts, it's going to refract as if it came from the focal point. So we're trying to be as accurate as possible, and then we're going to extend it back. Now the second ray we're going to do, we're going to aim it at the secondary principal focus. And then the refracted ray is going to come off parallel to the principal axis, like that. Now we're going to extend that ray back, parallel to the principal axis, and we get that. Now we could draw a third ray through the optical center, but we already have two. We already found where the virtual rays are coming back to meet, so that's good enough for now. Now we can use that information to draw our image. The head of our image is located right where the two rays meet because that's where the original ray started. And we have our image. Ray diagrams, diverging lenses. Diverging lenses always produce the same images. Smaller operate virtual and on the same side of the lens as the object. We see this image by extending the diverging rays backwards in a straight line to a virtual source. And that's what we see here. This guy is smaller, upright, between the focal point and the optical center, and it's going to be a virtual because it's virtual rays that create the image. And that concludes our lesson on drawing ray diagrams for lenses.